So welcome to First Take Math. This is part 2 of the square root. We're going to simplify what we call square root expressions. The strategy in a nutshell is basically we're looking to pair up the factors. As we learned with square root, a square root you had to have two of the same factor to take the square root of something. So we're going to look at a couple examples here. So we're going to simplify the following. We're going to simplify the square root of 8. The way this works is we first off just do the prime factorization of the 8. As we kind of learned, we can kind of use this T-chart. We also remember that the 5 prime numbers that we want are the 2, the 3, the 5, the 7, and the 11. Those are really nice tools in breaking down a number in prime factors. So does 2 go into 8? And we see that 2 does go into 8 4 times. And then we're now to the 4. Does 2 go into 4? 2 does go into 4 twice. And 2 goes into 2 one time. And again, when you get to that 1, we know we're done. And this left side becomes our factorization. So the square root of 8 changes into 2 times 2 times 2. And we learned that if a factor repeats twice, then we can pull that factor out one time. So for every pair of 2's, I can bring out a 2. So since I have one pair of 2's, I can bring out a 2, and I'm left with a 2 in the radical. So we have 2, the square root of 2 as our answer. And this is what is referred to as simplified. This is also denoted as an irrational number, because if you put this in a calculator, you get some strange decimal. So I'd encourage you to play with the calculator on this. And again, this is what they call irrational. It's a strange number. Looking at this next example, the square root of 24. Again, an easy strategy is to break it down into prime factors. So we're going to break this down into, so using the 24, we're going to break it down using our 2, 3, 5, 7, and 11. Again, the 2 goes into 24 12 times, so we get that. The 12 can break down with the 2. 2 goes into 12 6 times. The 6 breaks down by a 2. 2 goes to 6 3 times. With the 3, we recognize that that's the next prime number, and we know that 3 goes into itself one time. So the prime factorization, again, is this left side here. So we can rewrite this as then the square root of 2 times 2 times 2 times 3. And what we're trying to do is look for pairs. And for every pair, I can bring out that factor one time. So since I got that pair of 2's, a 2 comes out, and we're left with this 2 times 3 inside here. We call these the leftovers. The leftovers just stay inside there, and we just put those back together, and we would say it's going to be 2 times the square root of 6. So we pull out what we can, and then the leftovers just stay inside there. And then this is what we call simplified. So 2 times the square root of 6 is our answer. And again, you can check these in a calculator, and you should get some strange decimal that represents the same thing. We also can do this with letters. So again, the number we can approach by using a prime factorization. Again, using the 2, the 3, the 5, the 7, and 11, we can break down that 16. So 2 is going to go into 16 8 times. The 8 breaks down with the 2. 2 goes into 8 4 times. The 4 breaks down with the 2. 2 goes to 4 twice. And then the 2 breaks down with itself. 2 goes to 2 one time. So what I'm going to do is rewrite this as then 16 is 2 times 2 times 2 times 2. The a to the third means a times a times a, since exponents mean repeated multiplication. And y to the fifth represents y times y times y times y times y. And so at this point, to simplify, we just pair them up. So pairing them up, we have a pair of 2's, another pair of 2's, we have a pair of a's, a pair of y's, and another pair of y's. So each time we have a pair, that factor comes out of the radical. So I bring out a 2 times another 2. I bring out an a, I bring out a y, and I bring out a y. And the leftovers stay inside here. So the 2's all came out, but this a and this y are called leftovers. They stay inside there, so the a times y remains. Now to clean up the outside. Well, 2 times 2 can be written as a 4. The a just comes in, but y times y can be written as y squared. So we can use exponents to put that back together. And then we have the square root of ay on the inside. And that's what we refer to as a simplified expression. Now, if you want to, you can kind of do this mentally without all of the hassle. Remember, square root means there's actually a little 2 here that we don't even talk about, but there's this little 2 here. But remember, the square root of 16 is what times what is 16, and we know that 4 times 4 is 16. So you could probably say, well, the square root of 16 is 4 without having to do all this prime factorization. We also know that this 2 tells me to pair up. Well, how many pairs do we have here? Well, that 2 goes to 3 one time. That tells me I have one pair of A's coming out, and there's one A left over. So it's like a division problem. 2 goes to 3, 1 A comes out with 1 A left inside there. 2 goes into 5. Notice that 2 goes into 5 twice. It tells me that 2 Y's come out. There's 2 pairs of Y that come out, and there's a Y left over. So I can literally do that mentally. So the square root of 16 is 4. 2 goes to 3 one time. It tells me an A comes out. And we also have an A left over. 2 goes to 5 twice, so 2 Y's come out with 1 left over. So that would be another way of doing it. For beginners, I would encourage you to use the prime factorization as a solid strategy. So that's going to conclude my lesson on simplifying square root expressions.